Bronze, which costs $9.10 per kilogram, is made by combining copper, which costs $8.90 per kilogram, with tin, which costs $9.50 per kilogram. Find the number of kilograms of copper and tin required to make 15.3 kilograms of bronze. Now, this is a mixture word problem. Mixture word problems are difficult. So what I like to do is I like to make a table where I have my object, right? So I have three of them, three objects. I have bronze, I have copper, and I have tin. I have my amount, so whatever the amount is in kilograms, I have that. I have a value of them, so in this case, the value is cost. And then from that information, I create an equation. That equation is going to be the amount times the cost for each object. Now, let's make our rows of our three objects. Okay, not the prettiest table in the world, but I'm not here to win any awards. All right, so let's take a look at the total thing, the end result, which is bronze. So I'll put that right here, bronze. Okay, what do I know? I want to make 15.3 kilograms of it. And I know it costs $9.10. So in order for me to come up with an equation for this, I need to find out how much 15.3 kilograms of bronze costs at $3.10, $9.10, and I'm going to multiply those two numbers together. So the number that we get when we multiply that is $139.23. Okay? Fun. Now, what else do we have? So that's object number one. I have copper. Copper costs 8.9 kilograms per per kilogram. I just said that. Copper costs $8.90. Do we know how much we have of this? No. So I'll call you X. Okay, so the equation that we have there is going to be 8.9x because I can just turn 8.90 into 8.9, multiply x to it, and there you have it. So that's our copper option. Copper, the name of the dog from The Fox and the Hound. Cute movie. Tin costs 9.5. Okay, so the cost for this is $9.50. That's tin. And do we know the amount? No. So this is where we have to be a little clever here. I don't know the amount of copper. I don't know the amount of tin. But what I do know is that the total amount is 15 plus 3. So going off to the side, if we knew we had 10 pounds of stuff and we knew we had 7 pounds of other stuff, wouldn't we find out what we have left over by doing 10 minus 7? We would. So if we know we have 15.7 kilograms of stuff and X pounds or X kilograms of other stuff, the other stuff is going to be 15.3 minus X. Okay? So something to remember, challenging for sure, but what that gives us is a distributed property problem of 15.3 minus X times 9.5. Now, when we set up an equation, I will change that around a little bit. Okay, but these are the two pieces of information that we have. Now, common sense would tell us that the copper plus the tin is going to equal the bronze. So what I'm going to do for the equation that I set up is I'm going to do 8.9x plus 15.3 minus x in parentheses times 9.5 equals 139.23. So I have 8.9x plus, and I am going to rearrange this to make it a nicer looking distributed property problem, 9.5 times 15.3 minus x equals 139.23. Step number one, distributed property. Okay, 9.5 times 15.3 is 145.35. 9.5 times negative x is minus 9.5x. Coming along for the ride, we have 8.9x and equals 139.23. Let's combine the two variables on the left side. 8.9x minus 9.5x is negative 0.6x. Now, you might be a little nervous by that negative, but we'll see what happens. We'll see what happens. Right here, I drop down the positive 145.35, okay, because that was positive. I may have forgotten a plus sign there. And that's going to equal 139.23. Let's subtract both sides by 145.35 from both sides. Cross u out, and we get negative 6.12. So drop down the negative 0.6x, and we now have a somewhat friendlier problem to deal with. Let's divide both sides by negative 0.6. Divide both sides by negative 0.6. So if you were nervous about all those negatives, you'll be happy to know that the negative and the negative cancel each other out. And what you get is x equals 10.2. Now, what does that mean? The x that we had over here is the amount of copper that we have. So we have 10.2 kilograms of copper. They want us to find copper and tin. How do we find tin? Well, tin was 15.3 minus x. So let's go somewhere down here and do 15.3 minus the x that we got was 10.2. And 15.3 minus 10.2 is 5.1. So 10.2 kilograms of copper, 5.1 kilograms of tin. And that's what we need to answer this problem. So mixture problems are very, very, very challenging. But the best thing to do is to make a nice little table like we did. It takes time, but we got it right. And it was so much fun.